Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. Today, in this video lecture, let us see a case study on effective irrigation system for crops using Internet of Things. The Internet of Things is a network of items that have sensors installed in order to send and receive data via the Internet. Autonomous vehicles, smart home thermostats, and wearable fitness gear are a few examples. Technologies including wireless subterranean communications, subsurface sensing, and soil based antennas are used in agriculture. With the use of these technologies, farmers are able to monitor the state of their land in real time and apply inputs like fertilizer and water precisely where and when they are needed. Keeping an eye on soil conditions in particular holds a lot of potential for improving farmers' water usage practices. Irrigation systems can now wirelessly incorporate sensors to give users real time knowledge about the moisture content of the soil. According to studies, this tactic can lower irrigation water requirements by about 20% to 70% without negatively affecting the crop field's everyday operations. Next, we will see about what is agricultural IoT. Agricultural practices can be implemented with effective water management even in arid regions like the Middle East and North Africa. However, climate change related extreme weather events are making that more difficult. Over the past 20 years, wildfires and recurrent droughts in the western United States have resulted in agricultural losses valued at billions of dollars. For decades, soil moisture has been assessed by water specialists to help with irrigation and water management decisions. Because it is difficult to collect manual soil moisture readings in production field located in remote areas, automated technologies have essentially supplanted handheld soil moisture equipment. A network of radios, antennas, and sensors known as the Agricultural Internet of Things collect crops and soil data in real time while the crop is in the field. These sensors and antennas are wirelessly connected to farm equipment to make data collection easier. Agricultural IoT is a comprehensive framework that can identify conditions on agricultural land, recommend activities in response, and communicate with farm equipment. Water conservation and irrigation system control are made possible by the autonomous connection of devices such as soil moisture and temperature sensors in the field. In addition to scheduling irrigation and keeping an eye on the weather, the system can also operate farm equipment like fertilizer applicators and seed planters, estimating the amount of nutrients in the soil and recognizing pests are two other uses. Next, we will see about the challenges faced in agricultural IoT. The first one is interoperability. Lack of standardization in devices and communication protocols make it difficult to integrate and exchange data between the systems. Next one is network coverage. Agriculture is often used in remote areas where network coverage can be limited, making it difficult to ensure reliable connectivity. Third one is cost. The cost of implementing IoT solutions can be high, particularly for small and medium size farms. Next one is data management. IoT generates a huge amount of data, and managing, storing, and analyzing these data can be a big challenge. Next one is cyber security. IoT devices are vulnerable to cyber attacks, and the security of agricultural data is very important to protect sensitive information and intellectual property. The last one is user adoption. Adoption of IoT in agriculture can be slow as farmers are often cautious about new technologies and may need support to understand and use it effectively. Apart from these challenges, there are several other challenges. Although installing these components in the ground presents obstacles, wireless data collecting has the potential to greatly improve the farmer's water usage efficiency. For instance, the working properties of antennas buried inside the soil that transmit the sensor data vary significantly based on the soil's moisture content. Since farmers work in fields with heavy machinery, antennas need to be buried deep enough to prevent damage. Moisture impacts communication between the control system and sensor network when soil gets wet. The signals that the system sends are weakened because water in the soil absorbs the signal energy. Also, obstructing signal transmission is denser. So, few solutions for all these challenges are as follows. It is possible to build smart antennas that modifies the system bandwidth and operation frequency to lessen the influence of dirt on subterranean communications. This antenna allows sensors buried in the top layers of the soil to communicate with irrigation systems at a distance of about 650 feet or more in real time about the status of the soil. Another solution is to use directional antennas to focus signal energy in a desired direction. Long range wireless subterranean communications can also be achieved with antennas that focus energy towards the air. A problem that persists in many rural places is the absence of high speed internet connectivity. For instance, numerous researchers have combined agricultural IoT with wireless subterranean sensors in center pivot irrigation systems, but farmers lacking high speed internet connectivity are unable to implement this type of technology. In places where broadband connectivity is still unavailable, agricultural IoT integration with satellite based network connectivity can help disconnected farms. Additionally, researchers are creating drone powered agricultural IoT solutions that are mobile and installed to vehicles. These kind of systems can offer constant field connectivity, enabling more farmers in more locations to have access to digital technologies. Seasonal changes and crop growth cycles can temporarily alter operating conditions for agricultural IoT equipments. Scientists can help the agricultural IoT respond to changes in its environment by using cloud computing and machine learning. These networks also need to adapt to changing local conditions such as temperature, rainfall, and wind. Also, data management can be achieved using cloud. The importance of cybersecurity is growing as the agricultural IoT also keeps developing. Farm networks require sophisticated security solutions to safeguard the data they transport. Solutions that make it possible for academics and agents of agricultural extension to combine data from several farms are also required. By combining the data in this manner, producers' privacy will be protected and more precise decisions about things like water use may be made. Thank you for watching this video.